This conference will now be recorded.
Good morning, students. In today's class, I'm going to explain about what are the different methods of RH criteria to find the stability of a control system. See, yesterday class we discussed right how to construct the row array. So row array means the way of your constructing the row RH criteria, that is called as row array. Now in this class, I'm going to explain about how many methods we can implement that RH criteria and what are the different methodologies and what are the difficulties we can face while solving the RH criteria. Let's start the problem. Right. First of all, I will show you that one example based on the stability in real-time application. So stability in the sense of if there is any mismatching is happened in the system, there will be entire collapse will be happen. Okay, I will show you one example. Then you can get clarity. What is the stability? How the stability is acting a vital role in the system performance. So this is the one of the example in real-time application based on the stability. So stability in the sense the each and every component in the system has to be working proper way. If any one mistake is happen, that will be results is the entire collapse. Okay. So you can see in the image. So one of the famous example of unstable system. So unstable means there is some mistakes happen in the system, then you can get the collapse. Okay. So this is the dramatic photograph showing the collapse of the Tacoma Narrows suspension bridge on November 7, 1940. Okay. So if you take any stability system, they are taking the example of this. Okay. So in we have that you can see the two figures, figure A and figure B. So the figure A photograph showing that the twisting motion of bridges center span just before failure. See here, there isn't the failure happened in this reason, that is twisting, right? Now a few minutes after the first piece of concrete fell, this second photograph shows a 600 feet section of the bridge breaking out a suspension span and turning upside down as it is crashed in Puget Sound, Washington. Okay, so now if the stability is not working properly, so if this condition is taken as an unstable condition, due to this your system should be like this. So when you can face the unstable system, then your system should be collapsed in this way. So that's why I'm showing the example like this. You know, so that's why in every control system we are mainly concentrating on the stability condition. Then only we can avoid this type of failures in the system. Right. So this is the example for stability. Right. And this is the graph you can see here how the stability we can formulate based on the location of poles. And okay, so this is the graph, and the region you can see here, that is assigned by the lines. This region is called as unstable region because if some of the roots is lying on right hand of S plane, so this is S plane, this is right hand side and it is left hand side. Some of the poles, if any one, at least one, then you can say the system should be unstable region. So stability region means according to the roots obtained by the chaotic equation. Okay, whatever roots we are getting from the chaotic equation, that one of the roots should be lying in this RHS side. Okay, in real part side, then we can say it is a completely unstable region. Suppose if all the roots are lying in this region, then we can say stable region. And if some of the roots are lying in this imaginary axis, then we can say margin. So you have to be remember these three conditions: stable, marginally stable, and unstable. Okay. So then only you can say that how the system is working, either in stable region or marginally stable region and unstable region. Wait one thing. Right. Based on the location of roots, we can say we can categorize three categories: stable, unstable, and marginally stable. Next. So these are the three conditions we can discuss discussing about in this third unit. So how the system will be: stable system if the natural response approaches zero as time approaches infinity. So this is the condition for stable system. Unstable system if the natural response grows without bound as time approaches infinity. So we can simply say that bounded input and bounded output, then we can say the stable input. And whatever you are giving the input, that a particular output you will get based on the input. So that is called a stable system. So but if you are giving the proper input but you can't able to get the proper output, so that should be affected by the external disturbances or internal disturbances, then it is called as unstable system. And marginally stable means, suppose you are getting the output should be it is nearer to the expected output, that we can call as marginally stable. So these are the three conditions based on the stability of a control system. Right. So this is the construction of Routh-Hedge criteria, and it is also called as Routh array. So so we can say, so sometimes you can say that the value so in 2 marks question, so construct the Routh array like that. Okay, so this is the Routh array. So this is the way of construction. Okay, now the number of roots in the open right half of West plane is equals to the number of sign changes in the first column of Routh array. Now this is the first column, right? Now the number of sign changes is nothing but the number of roots lying on right half of West plane RHS side. Okay, so that is the representation of. So when if there is any sign changes in the first column, suppose first two positive and negative, and then positive, negative. So if the changes like this means, then how many times are sign changes, then that much of roots are lying on each side. So we can say this system is unstable system. Next, So these are the rules and regulations we have to be follow in the RH criteria. The first one is, if there should be no missing term. Okay na? So if you consider this equation, 3s square 4s cubed 5s and 1, so there is no s square term. So here in the place of s square term you can keep 0. Okay, next, all variables should be of same sign. Suppose if the sign should be like this, means then we can say there is a chances to get that unstable condition. Okay, right. So these are the two rules we have to be follow in the Routh-H criteria. Now we will see that one simple example based on this equation. Now this is the transfer function. Now we have to be find that characteristic equation. The characteristic equation is, first of all you have to find the transfer function from this. That is, it is a negative feedback, right? G of s divided by 1 plus g of s and h of s. So this is the transfer function, and the denominator shows that characteristic equation. Okay, first of all you have to find like this, or else you can directly find by this equation, 1 plus g of s h of s is equals to 0. So this is the formula for characteristic equation. So direct term E equals substitution, then you will get so if you substitute directly in that, 1 plus 1 divided by s cubed plus s square plus 2s plus 23 into 1 is equals to 0. Now from this I can write s cubed plus s square plus 2s plus 23 plus 1 is equals to 0. So finally you get, this is the characteristic, s cubed plus s square plus 2s plus 24 equals to 0. Now this is the characteristic equation. So in exam they will ask, so find the stability of the given characteristic equation. And our characteristic equation sir danchi man kanukkoli. Okay, if you see this characteristic equation, the higher order is 3, that is odd number. Okay, so what you have to do means, first of all you have to note it down the all s coefficients in downwards. S cubed, s square, s power 1 and s power 0. S power 0 means constant term. And then so 3 is higher order, right? That is odd coefficient. Now you have to find, you have to be formulate the first row. First row మీరు odd coefficient design చేయాలి. So odd coefficient ఏమొస్తాయి? What are the odd coefficients in this equation? What are the odd coefficients? In s cubed, right, 1 and 2. So this one, so we have to write 1 and 2. Next to second row, we can calculate second row, you have to formulate that even coefficient, that is 1 and 24. So first two rows you have to be formulate based on the characteristic equation. Okay, right? Based on characteristic equation, then you can formulate this equation. Now you have to find this s1 row and s power 0 based on the equation we have, right? So actually AD minus BC, this is the formula we have, but here BC minus AD, so that we have to be done. Okay, it's ABCD. So BC means 2 minus 24 divided by 2. What will get? Minus 11. 2 minus 24, that is minus 22 by 2, that is minus 11. Minus 11. Next, so there is no term here, right? Then you will get 0 here. Okay, now next, these two multiply, minus 11 into 24 minus 1 into 0 is 0 divided by minus 11. So what will get? 24. So now your row array is over. So row array construction is over. Now you have to check that first column. How many times our sign changes? So this is the first column of row array. How many times? 2 times. So first past, so from positive to negative and negative to positive. So it means that there are 2 times of sign changes. It means that it means that 2 roots are lying on right half of S plane. Okay. So just comment on the stability. So you can write it is unstable system and 2 roots are lying on R side because of there are two times or sign changes. Okay. Let me check this answer is correct or not. Right. See here. 1 minus 22 and 24. So it means that here there are 2 times or sign changes. Okay, from 1 to minus 22. So 1 time minus 22 minus 24. See, route array for closed loop control system. So first sign change, second sign change, and the output is this one. So you have to write like this. It is an unstable system, and in this given problem, there are 2 times of sign changes. Due to that, there are 2 roots are lying on right half of S plane. So that is the result you have to be right. So this is the normal growth array. Okay, normal condition. So there are 2 special cases. Let me see that what are the 2 special cases. The first case, route table has 0 only in the first column of array. Okay, suppose if any one element in the first column is 0. ఏదైనా ఒక ఎలిమెంట్ అనేది 0 అయితే that is case 1. In case 2, route table has entire row that consists of zeros. అంటే ఒక రో మొత్తం zeros అయితే సో ఇది సెకండ్ కేటగిరీ. సో మొత్తం మనకి 3 categories ఉన్నాయి. నార్మల్ route array. Second one is if one of the element in the first column is 0, and third case is if entire row any one row is becomes 0. So these are the 2 special cases we can see in the route array. So we will discuss this type of problem. So manku 3 types of problems. Normal route array, and one of the element is 0, and third one is ఒక entire row zeros అయినప్పుడు. సో అది ఎలా సాల్వ్ చేస్తాం ఇప్పుడు చూస్తాం. అండ్ ఫోర్త్ కేటగిరీ కూడా ఉంది. సో ఫోర్త్ కేటగిరీ ఏంటంటే సపోజ్ మీకు ఫస్ట్ కాలం లో ఒక అన్నోన్ వాల్యూ ఇస్తారు అంటే k గానీ సో k వాల్యూ ఇస్తారు అనుకోండి. Suppose you will get one k value in this first column. You have to be identify that what is the k value is required to stable condition. And k value, for example, suppose you having that here 3k. ఇప్పుడు 3k వచ్చింది ఓకేనా 3k వచ్చినప్పుడు then what is the value of k, then it makes the stability. ఇప్పుడు k value ఎప్పుడు స్టెబిలిటీ అవుతుంటే when k is greater than 1, గ్రేటర్ దాన్ రిక్వెస్ట్ అంటే k అనేది 1 అన్నా గ్రేటర్ దాన్ 1 అంటే ఇక్కడ ఏమవుతుంది పాజిటివ్ వాల్యూ అవుతుంది అంటే స్టేబుల్ అవుతుంది. సపోజ్ ఇప్పుడు k is less than 1 అనుకో మైనస్ అవుతుంది అప్పుడు అన్స్టేబుల్ కిందకి వస్తుంది ఓకేనా. వాడు కండిషన్ అడుగుతాడు వాట్ ఈస్ ద వాల్యూ ఆఫ్ k ఇఫ్ ద సిస్టమ్ ఈస్ స్టేబుల్. సో స్టేబుల్ అవ్వాలంటే k వాల్యూ ఎంత ఉండాలి. సో ఇది వచ్చేసి ఫోర్త్ కేసు సంబంధించింది ఓకేనా. సో లెట్ మీ సీ దట్ వన్ బై వన్. సో మీకు థర్డ్ యూనిట్ నుంచి చాలా ఈజీ క్వశ్చన్ అంటే ఇదే. సో మీరు ఈజీగా రాసేయచ్చు అండ్ యూ కెన్ గెట్ దట్ గుడ్ మార్క్స్ ఇన్ దిస్ కాన్సెప్ట్ ఓకేనా. సో ఫస్ట్ ఎగ్జాంపుల్. సో ఆల్ ఆఫ్ యూ నోట్ డౌన్ దిస్ ఈక్వేషన్. సో రైట్ డౌన్ క్వశ్చన్, ఫైండ్ ద స్టెబిలిటీ కండిషన్ ఫర్ ద గివెన్ క్యారెక్టరిస్టిక్ ఈక్వేషన్ అండ్ కామెంట్ ఆన్ ద స్టెబిలిటీ. ఫైండ్ ద స్టెబిలిటీ కండిషన్ for the given characteristic equation by using RH criteria and comment on the stability. Now first we have to be you have to write down like this. So in the given characteristic equation the higher order is 5. So in route array the first row is arranged by the odd coefficient and second row is arranged by the even coefficients. So ఆ విధంగా రాయాలన్నమాట ఓకేనా. నెక్స్ట్ now if you first of all you have to be write down that s coefficients in decreasing order, s power 5, s power 4, s cubed, s square, s power 1 and s power 0 okay. Now in this equation the odd coefficients are s power 5, s cubed, 11. So 1, 2 and 11. So 1, 2, 11. This is the first row. So first row is designed by whatever higher order is. If it is even number then you can write that even coefficient. If it is odd number you can write that odd coefficients. Next second is 4, that is even number right. So you can write 2, 4 and 10. ఓకేనా. సో మీరు దీన్ని సింప్లిఫై చేసుకోవచ్చు, అంటే 1 2 5 కూడా వేసుకోవచ్చు లేదా డైరెక్ట్ గానే వేసుకోవచ్చు. నౌ ఇఫ్ యూ సింప్లిఫై, ఇప్పుడు ఎస్ క్యూబ్ రో ని అరేంజ్ చేయాలి. వీ హ్యావ్ టు బి ఫార్మ్ ద ఎస్ క్యూబ్డ్ రో. ఓకేనా. హౌ వీ కెన్ రైట్ 2 into 2 that is 4 minus 4 divided by 2. So 0 by anything is 0, right? So you will get 0. Next 4 into 11, that is 44, minus 2 into 10, 20 divided by 4. So what will get? 22 divided by 4. So 2 2s are 2 11. So 11 by 2 you will get approximately 2 6. Okay now. Now if you so మనకి ఇప్పుడు కేస్ 1 వచ్చిందా. సో one of the element is 0. సో ఇప్పుడు ఏం చేయాలంటే, if 0 appears in the first column of non-zero row in row 3, just replace it with a small positive number. Again, now I am going to be replace this 0 by epsilon. Suppose if you place the epsilon, then you can simply s square. So 4 into epsilon minus 60 2 6 is 12 divided by epsilon. Okay, next 6 into 2 6 into 10 minus, so ఇక్కడ 0 ఉన్నట్టు 60 minus 0 divided by 6, so 10 you will get. Okay, next s power 1, this one into 6, this one, so you will get 6 here. Okay, so final ga there are two sign changes happen. So it means that two sign changes in the first column. So I will explain you clearly here. So 1 2, so first ఇక్కడ epsilon పెట్టుకుంటే 4 epsilon minus 12 divided by epsilon, 6 into 10 divided by 6, so you will get 10. Okay na. Next this one into, so 4 epsilon minus 12 divided by epsilon into 6 minus 10 epsilon divided by 4 epsilon minus 12 divided by, so if you simplify all these things you will get 6 here and here 0. 6 into 10 minus 0 divided by 6, you will get 10. Okay, now if you place epsilon is 1, so 1 place చేస్తే, then what you will get here? If you place 1 here, so you epsilon మీరు ఎప్పుడు ప్లేస్ చేయాలంటే it should be greater than or equal to 1, so ఇది పాజిటివ్ ఉండాలి. If you take that epsilon is equal to 1, then you will get 4 minus 12 divided by 1, so you will get minus 8. So minus 8 అనుకుందాం ఇక్కడ minus 8, so ఇక్కడ minus 8 ఇక్కడ 1 తీసుకుంటే, then how many types of change from here to here one time and here to here second time. So it means that two sign changes in the first column. There are two roots on RH side. Okay na, RH side చేసుకోవాలి. Okay na. So ఇప్పుడు suppose if you take that 2 also 4 to the 8, so you will get the negative value. So it means that the epsilon, if you take that epsilon is equal to 1, then the system should become unstable condition, because there are two sign changes. It means that two roots are lying on RH side of S plane. So this is the case 1 type. So case 1 లో ఏదో ఒక వాల్యూ అనేది 0 అవుతుంది. ఆ 0 ప్లేస్ లో ఎప్సిలాన్ పెట్టుకుంటే మనకి ఈ విధంగా ఒక ఈక్వేషన్ లాగా వస్తుంది. In this equation, if you substitute epsilon equals to 1 and epsilon, so ఇది ఎప్పుడు 1 కన్నా గ్రేటర్ 1 లేదా 1 కన్నా గ్రేటర్ దాన్ ఉండాలి. ఇట్ నెవర్ బి 0 అండ్ నెగటివ్ వాల్యూ. ఓకేనా. సో పెట్టుకున్నప్పుడు ఇక్కడ 1 పెట్టుకుంటారు. Then if you substitute this value here, then whatever value you get, so sometimes if you get positive value, then it becomes unstable condition. But in this case you are getting that minus value, right? So that's why there are two sign changes in the first row, so first column, then two roots are in RH side. Okay, so this is the case 1. Next we will see the case 2. Case 2 means if entire rows are becomes 0. సో మొత్తం రోస్ 0 అనే ఒక రో మొత్తం 0 అయినప్పుడు దాన్ని ఎలా సింప్లిఫై చేయాలని ఇప్పుడు చూస్తాం. రైట్. ఎగ్జాంపుల్ ఆఫ్ స్పెషల్ కేస్ 2. Determine the number of right half planes poles in the closed loop transfer function. Okay, now see here, this is the characteristic equation. So I'm going to write it here s power 5, s power 4, s cubed, s square, s power 1 and s power 0. So you have to write like this. Here The higher order is 5, right? That is odd number. So you have to be arrange that first row with odd coefficient and second row with even coefficient. So what you will get? Odd coefficient first row. First row coefficient ఏమొస్తుంది చెప్పండి? What are the values you can get in first row? 1, 6, 8. Because S4, 5, 1, 6, 8. Next second row 7, 42, 56. 7, 42 and 56. So there is any changes? 7, 7, 6, 42, 7, 9. So 7 table to divisible అయితే ఏమొస్తుంది చెప్పండి ఇక్కడ? If you divisible by 7, 7 1 7, 7 6 42, 7 8 56, 1 6 8. Okay. Now, if you see this, if you want to find that the S3 row, okay, 1 into 6 6 minus 6 divided by 1. So 0 by 1 is 0. Next 6 into 8 minus 6 into 8 divided by 6, then you will get 0. So you can see here this entire row becomes 0. Now in this condition what you have to do means you have to be considered that the upper row of this 0 row. So దీనికన్నా పై row ఏముంది ఇది ఉంది. So you have to take this equation. So s power 4 ఈ విధంగా రాసుకోవాలి. You can consider this equation, then this equation we can call as auxiliary equation. Auxiliary equation. Okay. So ఈ ఈక్వేషన్ ఎలా తీసుకుంటే చూపిస్తాను. Right. See, to solve it we will form a polynomial in the form of auxiliary equation. So 1 6 8. So ఇక్కడ first s power 4 ఉంది కాబట్టి so it is a even coefficient, right? s power 4 s square s power 0. So దీని ద్వారా కూడా మనకు వచ్చింది ఫార్మేషన్ ఇది. So s power 4 plus 6s square plus 8 is equals to 0. This is called as auxiliary equation. దీని తర్వాత so I am going to be assume it is a. Now we have to be differentiate a with respect to s. So dA by ds చేస్తే then what you will get? 4s cubed, then 12s is equals to 0. Okay, 4s cubed plus 12s is equals to 0. Now this third row again you can write. Third row మళ్ళీ రాసుకోవచ్చు. ఎలా రాసుకోవచ్చు అంటే 4 12 గా రాసుకోవచ్చు. ఓకేనా. సో ఇప్పుడు మనకు ఈ ఆక్సిలరీ ఈక్వేషన్ కన్సిడర్ చేసుకుంటే 0 రో కి పైన ఏ రో ఉంటుందో దాని నుంచి ఒక ఈక్వేషన్ ఫామ్ చేయాలి. ఓకేనా. అది ఈక్వేషన్ అనేది ఇక్కడ s4 ఉంది కాబట్టి ఈవెన్ కోఎఫిషియంట్ తో మల్టిప్లై అవుతుంది. ఒకవేళ s క్యూబ్ అంటే s క్యూబ్ ప్లస్ s ఆ విధంగా మల్టిప్లై అవుతుంది. ఓకేనా. ఆక్సిలరీ ఈక్వేషన్ ఫైండ్ అవుట్ చేసిన తర్వాత దెన్ యూ హ్యావ్ టు బి డిఫరెన్షియేట్ విత్ రెస్పెక్ట్ టు ద s. సో మనకి ఇప్పుడు s క్యూబ్ టర్మ్ లో వచ్చింది. సో దెన్ వీ కెన్ ఫార్ములేట్ దట్. సో ఇప్పుడు మనకు జీరోస్ వచ్చినది s క్యూబ్ లైనే కదా. సో s క్యూబ్ రోని ఇప్పుడు మనం అరేంజ్ చేయొచ్చు. సో 4 12 తో దెన్ యూ కెన్ ప్రొసీడ్ ద రిమైనింగ్ ప్రాసెస్. సో ఒకవేళ s క్యూబ్డ్ అంటే 0 వచ్చింది కదా ఈ 3 s క్యూబ్డ్ రోని దీన్ని 4 12 తో రీప్లేస్ చేస్తే ఎలా ప్రొసీడింగ్ అవుతుందో చూసాను. రైట్. Now you can see here the s cubed is replaced by 4 12 and 0. Okay, now so 4 1 the 4 4 3 8 so you can guess it, then you can get the remaining column. Okay, now so remaining ఈ విధంగా వస్తుంది మొత్తం. Since there is no sign changes, so there are no poles on right half of s prime, then the system is stable. This is the case 2. So case 2 లో ఈ విధంగా చేయాలి. ఫస్ట్ ఆక్సిలరీ ఈక్వేషన్ ఫైండ్ అవుట్ చేయాలి. దెన్ వీ హ్యావ్ టు బి డిఫరెన్షియేట్ విత్ రెస్పెక్ట్ టు s. ఆ వచ్చిన ఈక్వేషన్ ఇచ్చే కోఎఫిషియంట్స్ ఏదైతే 0 వచ్చిందో ఆ 0 దగ్గర రీప్లేస్ చేయాలి. చేసిన తర్వాత నెక్స్ట్ రిమైనింగ్ స్టెప్స్ మనం నార్మల్ రో తో ఎలా డిజైన్ చేసామో ఆ విధంగా. సో దీస్ ఆర్ ద 2 స్పెషల్ కేసెస్ ఇన్ RH criteria. You will see the next one, right? So ఇది స్పెషల్ కేస్ అన్నమాట. So and sometimes they will ask in constant value like this. Okay, so let me see that how we can find this kind of problems. Okay, You find the value of controller gain kc that make the feedback control system of the equation is stable. అంటే ఇక్కడ k వాల్యూ అనేది ఎంత ఉంటే ఈ సిస్టమ్ అనేది స్టేబుల్ అవుతుంది. That we have to be identify that. Okay. Now let me see that how we can arrange that route array this kind of equation. So ఇది fourth case అన్నమాట. Okay. So ఇది simplify చేస్తాను చూడండి. So I'm going to be simplify this. Just 10s cubed plus 17s square plus 8s and this entire is constant 1 plus kc equals to 0. Now we are going to be find that what is the value of kc. It makes the system stable. So first I am going to be arrange that route array s cubed s square s power 1 and s power 0. So the higher order is odd number, right? You have to write that odd coefficients. 10 yes, next 17 1 plus kc. You can write so 10 8, right? This is 10 8. So ఇక్కడ 5 2 5 are 2 4 ఈ విధంగా రాసుకోవచ్చు 5 4. ఓకేనా? సో దీన్ని ఇప్పుడు s1 రో ని ఫైండ్ అవుట్ చేయాలంటే 17 into 4 minus 5 into 1 plus kc divided by 17. So దీన్ని సింప్లిఫై చేస్తే ఎలా వస్తుందో చూసాం. So if you want to simplify this, (17 into 4) that is 68 minus 5 kc divided by 16. 63 minus 5 kc divided by 17 and here it will be 0. Okay, next s power 0 ఏమొస్తుంది ఇది into ఇది minus 0 divided by, so you will get 1 plus kc. ఇప్పుడు kc వాల్యూ ఎంత అయితే ఈ ఫస్ట్ కాలం మొత్తం పాజిటివ్ వాల్యూ వస్తుంది. ఓకేనా? see here the kc value should be -1 and 12.6 ఈ మధ్యలో ఉంటేనే స్టేబుల్ అవుతుంది. సపోజ్ if you, so ఎలా అంటే చూడండి, if kc value is equals to -1 సబ్స్టిట్యూట్ చేస్తే ఏమవుతుంది, ఇది 0 అవుతుంది. సో you can't able to substitute -1, so I am going to be kc is equals to 0 సబ్స్టిట్యూట్ చేస్తాం. If you substitute 0 then you will get the entire positive, so 0 తీసుకోవచ్చు. ఓకేనా? నెక్స్ట్ kc is equals to 1, so it should be a positive value. ఇప్పుడు kc is equals to 12.6 తీసుకుంటే, so let me see that 5 into 12.6 63. ఓకేనా? అంటే 12.6 వరకు అంటే 0 -1 తీసుకోకూడదు, 12.6 తీసుకో. ఇప్పుడు 12.6 తీసుకుంటే 0 అవుతుంది. ఓకేనా? సో యూ కాంట్ ఏబుల్ టు టేక్ -1 ఆర్ 12.6, ఈ రెండింటి తీసుకోవద్దు. దెన్ యూ కెన్ టేక్ ఎనీ వాల్యూ ఇన్ బిట్వీన్ దిస్ రీజన్. -1 కానీ లేదా 12.6 కాకుండా ఏ వాల్యూ తీసుకున్నా ఈ సిస్టమ్ అనేది స్టేబుల్ అవుతుంది. see here c1 will be positive if kc is greater than -1. ఓకేనా? ఇది ఒక కండిషన్. kc is less than 12.6, then is the condition. Okay, so we conclude that the system will be stable if kc value should be lies in between -1 and 12.6, but it not exact -1 and it is not exact 12.6. It should be lies in between these two. Okay, so this is the fourth category to find out the unknown value of gain. So this we can call as gain value. Okay, సో ఈ విధంగా మనకు 4 types of problems అనేవి RH criteria పైన అడుగుతాడు. ఫస్ట్ ది నార్మల్ row array, second one is if one of the element in the first column is 0, and third case is if entire one of the row should be zeros, then the fourth one is to find out the unknown value, that is gain value. Okay, so these are the 4 and we'll see that one by one. The first problem is the characteristic equation of system is given below. Determine the stability of the system. Okay, so ఈ విధంగా మీకు క్వశ్చన్ అవుతుంది. అంటే ఒక క్వశ్చన్ లో ఈ విధంగా 3-4 ఈక్వేషన్స్ ఇస్తారు. 3-4 ఈక్వేషన్స్ ఇచ్చి ఫైండ్ అవుట్ ద స్టెబిలిటీ కండిషన్స్ ఆఫ్ ద ఫాలోయింగ్ క్యారెక్టరిస్టిక్ ఈక్వేషన్ అని అడుగుతారు. సో నువ్వు అన్నిటిని రాయి. ఓకే, నౌ ఫస్ట్ ఆఫ్ ఆల్ you have to write the given characteristic equation has the higher order is 4 since it is even number. Now we have to be formulate that row array, the first column by even coefficient, the second column by odd coefficient. So even coefficients ఏమో సేమ్. సో s power 4 s cubed s square s1 s0. సో ఈ విధంగా డిసెండింగ్ ఆర్డర్ రాసుకోవాలి. నెక్స్ట్ you have to be write the first row with even coefficient. Even coefficient means s power 4 16 s square and s power 0. Okay, 1 16 6. So this is 6 or 5. So 5 is going to, so 5, let's take it is 5. Next, second column, second row, that is odd coefficient, that is 4 and 10, 4 10 and remaining. So ఇక్కడ మిస్ అయింది కదా, సో ఇక్కడైతే మిస్ అయితే అక్కడ 0 పెట్టేసుకుంటాం. ఓకేనా. నెక్స్ట్ you have to be find that rows of s power 2 s power 1 s power 0. ఓకేనా. సో s power 2 ఫస్ట్ ఎలిమెంట్ ఎలా వస్తుంది, 4 into 16 minus 10 into 1 divided by 4. So 16 4 the 64 minus 10 divided by 4. So you will get 54 divided by 4. 4 1s are 4 3s are 4 5s are 13.5. Next, second, 10 into 5 minus 0 divided by 10. So you will get 5. So 13.5 and 5. Next, s power 1, 13.5 into 10 minus 4 into 5 divided by 13.5. So you will get 8.52 and remaining is 0. And finally you get, so if you see this first column, all values having the positive sign. So in row array formed, if we see in the first column, all elements are positive, there is no sign change, hence the system is stable. And so how many roots we can append from this equation? Every roots of equation key. How many roots you can append? Right, 4. So 4 roots are lying on LH side, left half of S plane, because it is stable system. Okay, now? So this kind of problems you will get for normal Roth-Hatch criteria. So normal method lo ee vidhanga vastundi. Okay, now let me see that second example. Right. So this is the second one. Now the characteristic equation of the system is given below. Determine the stability of the system. So 4s square, 4s power 4, 8s cubed, 2s square plus 10s plus 3 equals to 0. Right. The higher order is 4, that is even number. You have to be write this in this decreasing order, s power 4, s cubed, s square, s power 1, s power 0. The first row should be formed by the even coefficient 4, 2 and s power 0. So 4, 2, 3. Next, second row is formed by 8, 10, 10, 0. Okay. Now you can see here there is 2 times of sign changes. So from 8 positive 8 to minus 3. So this is one time, and minus 3 to plus 8. So this is second time. So you can see in the first column of Roth array formed above, there is one negative element. Also there are 2 sign changes in first column. First is from 8 to minus 3 and second is from minus 3 to plus 8. So we have to write like this. Hence the system in question is unstable, and there are 2 roots are lying on RH side of S plane, right half of S plane. Okay, because there are 2 sign changes means 2 roots. Okay, 2 roots are lying on RH side. RH side ante right hand off side of S plane. Okay. Next, let me see the next problem. The characteristic equation of system is given as follows: s cubed plus 3s square plus 7s plus k equals 0. Find the range of values of k for which the system would be stable. Okay. Now the higher order is 3, that is odd number. So you have to form the first row by odd coefficient, that is 1 and 7. Second row by 3 and k. Now 3 7s are 21 minus k by 3, and finally you will get k. Suppose the k value should never be 0 and minus value, because if you facing these two, then you can say you can get an unstable condition, but the problem which is stable condition. So the k value is always greater than or equals to 1. Okay, so if you substitute k is equals to 1, what you will get? K is equal to 1 means 20 divided by 3, that is positive value, and k is equal to 1. So that is also 1. And it should be k is greater than or equals to 1. లేదా k 0, this k is greater than 0. Okay, next 21 తీసుకోకూడదు. So if you take 21, then you will get 0. So it means that the k value should be lies in between 0 and 21. Then only your system should be stable condition. So this is the way we need to find the range of k for stable condition. See here, 21 minus k is greater than 0 and k is greater than 0. So k should be greater than 0. That is the first condition. Next, k is less than 21, because if you take that 21 here, then you will get 0. So it may be 20, or so it should be less than 21. So you can get any value. Okay. So finally you can conclude that the k should be 0 within the limits of 0 and 21. Then only your system should be stable. Okay. So this is the third one. Next. Fourth one, the characteristic equation of system is given as this one. Determine whether this system is stable or not. Okay. So ikkada manaku case 1 సంబంధించి అదే one of the element is becomes 0 అంటే first column. So చేసిన తర్వాత after that you have to be replace 0 by epsilon, then you can find the epsilon value. So in this way. Okay. So now if you examine the elements of first column, so I am going to write here s power 5, s power 4, s cubed, s square, s power 1. So first row వచ్చేసి 1 3 2, second row వచ్చేసి 1 3 5. So these are the two rows, even first row and second row. Third row we can apply 3 minus 3 divided by 1, so you will get 0. 3 2s are 6 minus 15 divided by 3. So what will get 9 by 3 minus 3 will get, and 0 here. And so 0 into 3 0 plus 3, and so what will get divided by 0? So you will get infinity here. So that's why I am going to be replace 0 by epsilon. So you get 3 epsilon plus 3 divided by epsilon, and here 5 and 0. Okay na? So next దీన్ని సింప్లిఫై చేసే విధంగా వస్తుంది. ఇప్పుడు 3 epsilon plus 3 divided by epsilon, so it should be greater than 0. 3 epsilon plus 3 అనేది greater than 0 ఉండాలి, then only your system will be stable. Okay, so it's here 3 plus 3 epsilon should be greater than 0. ఒక కండిషన్ అయిపోయింది. నెక్స్ట్ రెండోది, సో రెండోది ఈ విధంగా చేసుకోవాలన్నమాట. సో 3 so if you take this all terms, if you simplify this minus 9 epsilon, so equal వస్తే then it should be less than 0. సో less than 0 అంటే epsilon వాల్యూ అనేది epsilon greater than 0 అంటే సపోజ్ 1 తీసుకోండి, ఇక్కడ minus 9 minus 5 and 3 అంటే 6 వస్తుంది. So you will get minus value here. So you can simply say that the epsilon value should be less than 0. ఒకవేళ less than 0 అంటే minus 1 తీసుకోండి, 9 minus 9 and minus 5. So less than 0 తీసుకున్నా సరిపోదు. So epsilon is less than minus 1 తీసుకుంటే then you can say some you can change the values. Okay na? So this is the way we can find that case 2 method. Okay na? So okay students, this is about today class. Okay na? So in tomorrow class also we will discuss some problems. So first of all you have to practice the problems. I already given in material and textbook. Just practice the questions. Okay na? Right. So okay students, I'm going to end this class now. Thank you.